Welcome to a workshop video from Touro University Graduate School of Technology. We're excited to host tonight's workshop that's going to cover machine learning, neural networks, and supervised learning. Please welcome Professor Behrooz Khorsandi, who will be hosting today's workshop video.
Hello everyone. How are you? I'm Lucian Tony, and I'd like to welcome you to tonight's workshop hosted by the Graduate School of Technology and our Artificial Intelligence program. One of our esteemed professors from our Artificial Intelligence program will be sharing tonight. Professor Behrooz, have a wonderful presentation tonight.
Thank you. Thank you for that introduction. Welcome, everybody. As you know, this field of artificial intelligence has grown by leaps and bounds, and there's tremendous amount of development going on, tremendous amount of innovation taking place in AI. And within a 60-minute time slot, we can only go through so much. I've tried to highlight as much to whet your appetite, get you interested in case you have never heard of AI, or if you've just started to understand what's talking about. As you just heard from our previous speaker, Touro has a complete, comprehensive program in AI courses, and I recommend that if you're interested to follow on with those additional courses. So what do we plan to go over tonight? First of all, we're going to get some definitions out of the way and talk about what is the scope of AI? What things does AI covers? What technologies does it embrace? We'll then jump into the concept of neural networks. What is the significance of neural networks, how they function? And again, all at a high level. We'll go into a little bit more detail into a number of AI workloads. These are practical workloads today in use as we speak. Then we'll focus on probably the largest component of AI, which is machine learning. Understand what are the various principles of machine learning. Wrap up the conversation by talking about AI in the cloud, why we're even considering running AI in the cloud, and should become clear to you by the end of this discussion. And last but certainly not least, responsible AI. This is a terminology that applies to ensure that leveraging AI does not violate security policies, does not violate privacy policies, and does not hurt individuals. So without further ado, let's jump into the first topic, which is fundamental concepts behind AI. The first thing I want to make sure everybody understands is that when we talk about artificial intelligence, as the term implies, the idea behind it is to create machines that simulate the way humans think, to copycat cognitive functions of human beings. So if you think about it at a high level, human beings learn something new. They use reasoning to understand, to make conclusions, and to help them solve problems. And we essentially want to see the same thing with the artificial intelligence. So essentially, we want the models to learn from past experience. We want them to be able to perform some reasoning, and at the end of the day, be able to solve problems. So at the high end, we want to make sure they mimic how humans behave. There are three major fields that we're going to touch upon in this slide. One is robotics. The other one is NLP, or natural language processing. And third, and certainly not the last one, is machine learning. So let's go through each one of these one at a time. The idea of robotics, you probably have seen it in some movies or television shows. Essentially, is an area of not only just computer science, but also engineering. And the purpose of robotics is to create machines that can perform jobs that humans used to do. Of course, the side result of this is the loss of some jobs. But if you look at the positive side of this, is that we are supposed to become more productive. Human beings can be put on jobs that are more meaningful, and we can let the robots take control of menial tasks. And you notice I've listed a number of sub-bullets in terms of robotics being used as in surgical robots. I've had a number of friends and family members that have gone through surgery rooms, and the robots are performing very precise operations. They're also being used in space exploration. Manufacturing, in fact, is a big user of robotics, where they allow the robots to carry or move components from one place to the other with very, very high accuracy. The second component that we spoke about regarding AI scope deals with natural language processing. As the term implies, the idea here is AI being able to understand the way human beings communicate. In fact, this is not necessarily a new field. This has been around since the mid-50s, as you're going to hear. But it's really the last few years where they have started to improve it significantly beyond what it could accomplish several years ago. The idea of natural language processing is to understand what human language is. And the way you explain to a machine, for AI to be able to understand what are the key words, does the order of the words matter, and which ones carry more significance. The third and the last one we're going to be talking about as far as scope of AI, and by the way, there are additional workloads you're going to see in a few minutes, is machine learning. This is by far the largest component of AI. And the idea of machine learning, as the term implies, is to enable machines to learn from past experience. Our experience is the data that we feed into the model. So essentially, as long as our past data is accurate, as long as our past data is large enough to make sense, then machine learning can do its job correctly. Notice I brought to you two very important caveats. The results that ML produces is as good as the data that we feed it. And in fact, what machine learning does, it leverages mathematical algorithms, it leverages data from the past to make predictions. That's really the new AI compared to what it used to be. In addition to making predictions, being able to discover patterns and structures. You can just imagine what the practical application of this would be in the health field, where the doctors can make diagnosis much faster, be able to determine anomalies in an X-ray picture that we have taken based on past results. So, and the idea of machine learning is to build an AI model that can actually come back and make predictions on data that we have not seen yet. That's really the beauty of and the most important part of AI. So a really brief overview of the history and evolution of AI is the fact that, as I mentioned to you, back in the mid-50s, that's where the AI research and exploration really took off. And we have gone through a lot of different phases. And now, as I just spoke about, we have seen machine learning and deep learning, which leverages neural networks, take place. And we're going to have some more explanation about neural networks in the next slide. But in the interim, what is this neural networks all about? As this picture also shows, the idea here is to create layers of nodes that are connected to each other. We call this artificial neurons, essentially simulating the way human brain functions. These neurons essentially receive a signal, they process the signal, and then transmit the signal. The familiar situation of input, process, output. So how do they work? Through electrical signals, through chemical signals. And these neurons then are subsequently used in understanding and recognizing speech, being able to classify images, which have become a fundamental part of our deep learning. So deep learning, the reason we call it deep is because it can perform complex analysis. It can perform complex data processing. And most of its job is done through algorithms. So there is that word again, algorithm. At a high level, if somebody asks you, how do you define the term algorithm? Think of algorithm as mathematical formulas. And while we're on that topic, understand that a lot of AI relies on mathematics, namely calculus, linear algebra, probability, and statistics, as well as other components of mathematics. So a lot of what we're discussing, like for example, later on when we're going to talk about bitmaps in terms of image recognition, bitmaps are going to be stored in matrices, which are a compilation of rows and columns. We'll talk about this when we get to it in the next few slides. So a couple of examples of it that you might not have realized that AI is actually embedded in our software is a good, clear example is Microsoft Office, Office 365 or Office 2024 or 2021. Essentially, a couple of examples are Microsoft Word can provide suggestions in terms of how you can provide clarity for your sentences. Or in Microsoft PowerPoint, if you've ever used it, there is this component called Design Ideas. What it does, it provides you suggestions in terms of how to enhance your layouts for your slides, what kind of themes are there based on what you're creating. So let's get a little bit deeper into these neural networks, and you see a pictorial view of this on the left-hand side. Essentially, again, as we said, the first bullet summarizes what we discussed in the previous slide, that they are inspired through the structure and the functionality of the human brain. And their job is to understand what are the patterns. Their job is to see how are the various data components are related to each other. And they do this thing through the way of copycatting, the way that the neurons work in our brain. So there are, as you can see in this simplified picture, there are layers upon layers upon layers of nodes that are connected to each other. These layers are called neurons. You notice there is an input, there is a processing, and there's a hidden layer, and finally coming down to an output layer. And what these networks will do, these neural networks do, essentially connect all these different neurons together. We assign weights to these neurons, and eventually we come up with a number. And as you're going to see in the next slide, we might have to go back, perform a trial and error until we get the result that we're looking for. These neural networks essentially learn to perform a number of tasks. Some of them are perform classifications where we have distinct categories of data. Perform regression, which is be able to extend, for example, a line of best fit among our various data points. Or if you look at Gen AI, the latest iteration of AI, being able to come up with new content. And how do we do this? By adjusting the weights when we train this model. And that brings us to a very important point that I have not listed here in this slide. As you go through, develop your models, it's very important to train the models. The same way you train a dog to fetch something, you train the dog to do something, to help you walk, go get something, etc. The same way you have to train an AI model. And you train the AI model by feeding it specific data. And during the test phase, you use some test data or dummy data to essentially see how well your model works. And in the next stage, you essentially scale that up with real production data, internal data, or data that comes from the internet. So how do these neurons work? As we said, the neuron receives input from other neuron. Once we receive that input, we process that out. And based on a formula that I'm going to show you in a minute, once a threshold is reached, then it sends an output signal. Until that threshold is reached, that particular neuron is not going to generate an output signal. And then that output signal goes on to the next layer, as you see in this pictorial. So here is the rub, as I was mentioning. Let me get this out of the way so I can demonstrate it better. So at a high level, there are three layers in our neural network: input, hidden, and output. You can think of hidden as the processing layer. So input essentially where the neural network receives the data, and then the hidden layers are these layers that are between input and the last layer, which is output, where they actually perform calculations. And as you saw in the previous picture, there can be several different layers until we finally reach the output, where the output is actually produced. Now, before we get to this formula that I've listed on the top, you need to understand that neural networks, again, use training. Training is based on three fundamental aspects. One is called forward propagation, which is the situation where the data goes from the input to hidden layer to the output. So that means the data is passed through the network to come up with an output. Once the forward propagation is completed and an output is produced, we calculate a loss mathematically. So we look at the output and we compare to the value. And based on that, we do an iteration, which means that the next step might have to be we got to go back because we propagate this error backwards. We have to go back and adjust the weights and redo this process over and over again until the calculation that we have, the output and the true value, come reasonably close within a margin of error. As you can imagine, this process, and we call this thing also in science, if you have ever worked in laboratory projects, you know, you go through an iterative process. If you're trying to solve a fourth or fifth degree mathematical equation, if you do not have formulas to figure out how you solve it similar to the way you solve a second degree equation, you come up with trial and error. You use a number, you find out does the result come to be higher or lower than the result on the equation, and then you continue this iterative process until your results are accurate or reasonably close. So what I've listed here is the way we calculate the output from this neural network. So first of all, we mentioned that every input value has a corresponding weight. 10%, 20%, and the sum of all the weights is going to add up to 100%. So my input value is then going to be multiplied by its corresponding weight, and then this is repeated for all different neurons. That's why you see this sigma sign, which repeats the calculation from 1 to n. N can be 3 layers, 4 layers, 5 layers, what have you. And the difference is here, we now add this bias layer, or what we call the bias term. So this is the bias that I was mentioning to you in this previous slide when we said that a certain threshold is exceeded. Threshold is actually that bias. So essentially you see that what we calculate, what we get out of these neural networks, which becomes our output, is sum of the input and the corresponding weight and the additional bias, which means we're now going to go back and not only adjust the weight, potentially might have to adjust the bias term based on what our calculation indicates. So the bias term is that threshold that I mentioned to you in the previous slide. The idea here is to shift the activation of that neuron to either to the left or to the right. Based on whether it goes to the left or the right, we decide how much input do we need to activate a particular neuron. So if the bias value is higher, that means that the neuron needs more input. More input indicates higher bias. Lower bias indicates that it can activate easier. At a high level, that's all we're going to discuss here so that we'll be able to get to the rest of the components of our presentation. So now we're going to talk about various AI workloads. Why I have included this slide here is so that you can see from a practical perspective what industry or what applications of AI are used so that we can leverage these AI. First one we're going to talk about is data processing. And in fact, if you look at majority of what's listed under data processing, this is what we call classical or heritage AI. The way this data processing works is by collecting data. And once it's collected it goes through an analysis. Let's look at a very practical example of this. When you use or leverage an email system such as Office 365 or Gmail as example, you know, certain times some emails are directed to your spam folder. So how does the email program make that determination? The answer is through an AI engine. So what the AI engine does, looks at content in the text, body of the email, looks at the content in the message header, looks at specific characters in the message. For example, if there is special words such as hurry, this is it, number of exclamation mark, just as an example, then it assigns a weight to it in terms of saying, okay, this is highly spam and suspicious, or this is just regular email. And by the way, the same thing applies to spam for text messages as well. Any social media posts. So the data that we get for performing, for training AI can also come from social media posts. Data that we use as an input can come from photographs and videos. So you can see literally not megabytes, not gigabytes, not terabytes. We're talking the order of exabytes and zettabytes of data that's out there essentially. And in fact, to that, you can even add values that are calculated from the sensors we have in our home, IoT, Internet of Things. They produce tremendous amount of data that can be used as input to our AI models, which is why all classified under data processing. As you heard me mention, model training. Models work with data, and that data is fed into these mathematical formulas we call algorithms. So the way it works is we try to gather as much as large a data set as possible, not only large, but also relevant. That means the data has got to be related to what we are talking about. And then what needs to happen is that the data has to be cleansed. Cleansing the data means remove the noise, prepare the data for actual production, then use an appropriate model. And you're going to see in a few minutes, there are various types of machine learning model that are in existence, and each one has their own practical usage. And obviously, as we said earlier, being able to adjust our parameters, go back, recalibrate, and come back with and validate the results. That's the idea of training an AI model. Another terminology that has become important in the world of AI is inference. Inference is essentially the process where your trained models are able to make predictions based on new data that they get. So if we had previously provided data, we had trained a model, they saw the results. Now, based on new data that we feed, and this data that has not been seen before, AI is going to be able to come up with an inference, which means what is the new prediction is going to be? Is it going to be raining? Can I go there play tennis? As you're going to see a model that I'm going to show you. Is it appropriate to start planting certain species in our fields? And finally, we refer to deploying. Deploying essentially means, for example, leveraging application programming interfaces, APIs, inside our programs to call appropriate AI modules. And that's how this functionality is being leveraged in real-world scenarios. Some more examples of common applications. Image recognition is a big one. Image recognition essentially is used extensively in healthcare. And I spoke about medical imaging, being able to do early detection of malignant cells in a body, as well as assisting during surgical processes. Speech recognition, being able to, maybe there are handicapped individuals and we need to accommodate them. We have to make it accessible to them. The way we make it accessible is through speech recognition, which means that as the individual speaks, the AI system has to be able to convert that spoken language into text, essentially providing hands-free. And remember that the idea of speech recognition is not being able to necessarily recognize words, but be able to make sense of the patterns inside the data. Then we have this recommendation system that a lot of companies use. For example, if you've ever used Netflix to pick shows, and over time, the Netflix system tries to learn your behavior. What do you want to watch most? Is it going to be a sporting event? Is it going to be a movie? Is it going to be a classical event, et cetera, et cetera? And based on that, their system can provide you content that's personalized to you, and maybe even provide additional products or suggest additional products to you. This recommendation system leverages what's called unsupervised machine learning. It's not supervised, it's unsupervised, because our data has not labels, as you're going to hear in a few minutes. And yet another common application of AI is to come up with predictions, predictive analytics, which means analyze what my data is going to look like, what's the future trend is going to be, what's our trend utilization is going to be, and why we're interested in this. You notice in today's world, whether it's in the world of sports, whether it's in the world of commercial business, we all are going to be bombarded with data. More data, the better it is for AI. AI does its job better, helps us with be able to make more informed decisions. Where are we going to install our new systems? What city is going to be where our next capital for developing certain products? So on and so forth. So another workload that we're going to be speaking about is going to be computer vision. Essentially, that means enabling machines to understand data that is captured visually. So how does it actually work? We process visual data. And again, similar to what we spoke about earlier tonight, the idea is to mimic the way a human being visualizes image. So in this example, we have image recognition, being able to figure out what objects are in a particular picture and being able to classify them. Classify objects, put them in specific distinct categories. And you notice I've included here 3 major fields. In the field of security, is this an intruder? Healthcare, is this a malignant cell? Autonomous driving, being these driverless cars, being able to make decisions as to, is this a stop sign? Do I need to slow down? Am I allowed to make a right turn? That's the idea of being autonomous driving behind the scenes. Then we have image processing. Image processing essentially means being able to better analyze and recognize our images. So that means we have to do some processing and to enhance our images. What are some examples? We might have to remove certain noise in our images, stuff that we are not interested in, stuff that is not of interest to us. Maybe we need to smoothen certain images. That's what computer vision has come to the rescue. Within an image, it's possible maybe we want to identify where are the edges. For example, maybe we're taking a land survey and it's important to understand the edges, especially if you're planning to do development. We want to make sure we do not step over the next door neighbor's territory. Be able to divide an image into meaningful segments and then be able to manipulate those segments individually. And finally, being able to transform that image essentially by changing its geometric structure. So in AI, specifically computer vision, we have object detection and segmentation, and both of these are quite essential in autonomous vehicles, as I just mentioned earlier. So understand that image processing is going to be very, very important. And recognition understanding is being able to, computer vision, identify who are the objects. Think of it as this way. One technology that maybe they use in cities is like, for example, if you have noticed in New York City, there are bus lanes, and bus lanes are reserved for buses. We want to make sure that they are not used by individual automobiles. So being able to identify what a bus looks like, identify what a non-bus vehicle looks like, essentially being able to facilitate these intelligent systems to make decisions and report back to humans. What about natural language processing? As the term implies, this is, first of all, this is a branch of AI. The idea of this natural languages processing is to help us communicate better, interact better with our target machines that are running AI. So what's some basics? We want to make sure machines can understand and they can also translate and think, what are we talking about? What are we saying? Which essentially helps us improve our interaction with computers. And what this is made up of is being able to recognize speech, as we discussed earlier, being able to understand language and translate it to different languages. Therefore, this becomes a global solution, and being able to also generate text accordingly. This is the Gen AI portion of this. Being able to recognize the speech that somebody is creating and being able to incorporate this inside voice-enabled applications, any application that gets enabled through voice. And finally, based on what is spoken, be able to generate text, which essentially helps automate creation of content. Something very important that to marketeers is this term called sentiment analysis. Sentiment analysis means being able to understand what's the mood of the customer, what's the mood of the end user, what is their emotional tone? Are they upset? Are they happy? Does this mean they're going to come back to us to purchase additional products? Are they giving up on us? So, and the way sentiment analysis works is by going through text data, be able to reveal how the user feels about our company or about our products. Another example of this component is categorizing text data. Categorizing text data means, hey, we go there and create predefined labels for them. And by creating predefined labels, it helps us organize our data and be able to interpret our data easier. And through sentiment analysis and through text classification, be able to obtain feedback from our users. And this is something a lot of companies look for, to see what are the clients are really thinking about us. Do they, at the end of the day, are they want to come back to us for more business, or potentially they're not necessarily interested? Language translation does not need any introduction. Essentially, it helps us become one global word by translating from the various different languages, and essentially allows us to even convert the text accurately. And this has improved over time. And not only that, be able to summarize. How many times you have run into a situation where you might be working for a consulting company? Consulting companies typically receive requests for proposals. These requests for proposals, especially from government agencies, are generally very large, in excess of 300 pages. Being able to go through these documents and be able to retain and understand what they're asking for can become a challenge. So through AI, through language services in AI, we can go through and summarize a document quite accurately and be able to make the information accessible to the end users who need to respond to the RFP, as a good practical example. What about conversational workloads? Well, first of all, what do we mean by conversational AI? Conversational AI means enabling machines to engage in conversations with human beings. And we not only use speech recognition, we also use natural language processing and machine learning. And this is an area that is significant in customer service. Essentially, you want to make sure that users are provided with enhanced experience, enhanced shopping experience, enhanced product experience. And not only that, being able to streamline communication between the organization and the end user. And you probably are all familiar with personal assistants that are available in Windows operating system and Siri in Apple, etc. Those are the personal assistants we're talking about, to be able to perform tasks through commands and interaction with spoken words. Chatbots, I'm sure you've heard about them. It's related to this topic that we were just discussing here about conversational AI, and their importance come in, again, for automating customer interactions. In fact, chatbots have become almost a first line of defense on probably 80 to 90% of the organizations out there, because now a chatbot can respond 7/24. You do not have to pay somebody to work on second shift or third shift, or even pay them a premium shift, to be able to answer very basic inquiries and providing an assistant to a user. Obviously, one of the important things, and you're going to see this thing in the concept of responsible AI, is for the client, the end user, the customer, understand that they're interacting with a bot and not a human being. So that purpose needs to be clearly communicated. Another example of chatbots functionality is to automate the customer interactions when they have inquiries. Where do I go to purchase particular merchandise? What floor do I have to go to return my equipment or anything that I have bought? Which at the end of the day helps improve user experience. So you can see chatbots and virtual assistants have a major play in this conversation. And the same thing with voice recognition, being able to understand human speech. Voice recognition essentially means that computer is going to process human speech. It's going to be able to understand it based on patterns, based on frequency of spoken words, and make the interactions with computers more natural. So, and through voice recognition technology, essentially machines capability of communicating with humans will be improved. So let's get to the next topic, which is what I mentioned to you about machine learning, which by far is the largest and probably the most important part of AI. First of all, machine learning is a subset of AI, and it works based on algorithms, mathematical formulas. And by training algorithms on first test data, and then on external data, and then on private data, we can train our algorithms to make better decisions. And as you can see on the bottom here, ML relies on statistical techniques to make its decisions. So there are generally three types of machine learning. One is called supervised, one is called unsupervised, and the other one is called reinforcement learning. Let's first of all talk about supervised. Whenever you're dealing with supervised learning, your algorithms get trained on data that has a label associated with it. So what do you mean by label data? We have gone through some process, taken raw data, and we assigned some kind of label. For example, label can say, this is date, this is text, this is calculated field, so on and so forth. And by adding these labels, you're providing some context or meaning to the data. Through these labels, we are essentially creating annotations. Through these annotations, the supervised machine learning is going to be able to understand from the data, learn from the data, help it make its decisions. Somebody actually said that these labels act as signposts. When you're on the road and you see signposts guide you to how to get to your final destination. What's the proper path to take? And the signposts that we have here as applied to supervised learning essentially guide the mathematical model, the algorithm, toward making accurate predictions. So what's two examples of this? We already spoke about spam detection. And another example is being able to predict house prices in a market. If you think about it, it helps you with predicting even continuous values, as you're going to see in a few minutes. On the opposite end of supervised learning is unsupervised learning, where supervised learning relies on labeled data. Unsupervised learning relies on unlabeled data. That means there is no tag, there is no label. We look at the raw data as is, so that means this requires a lot more processing. We have to be able to do a lot more processing to understand where these data belong together, how we can actually segment these groups of data together. If you think about it, that customer segmentation happens to be one prominent example. So for example, the way I would have a customer segmentation, maybe people in a particular zip code in the United States have a certain buying preferences. Certain people in a particular geography are interested to watch football on Sunday night. So this is what we mean by creating segmentation through unsupervised learning, through data that does not come with any tags. Then we have the third type of machine learning, reinforcement learning. Reinforcement essentially means we try to focus on learning by allowing the model to interact with our environment and being able to use a reward system or perhaps a penalty system. If they do good, we assign a reward. But essentially, the reward would be in the form of a feedback. Through providing feedback, we improve the outcome. So again, the reinforcement means by continuously learning, by continuously analyzing, by continuously providing feedback, almost like a cyclical model. When you go from one step to another and then you go back and repeat the process again, you improve the outcome that you get from your machine learning. So reinforcement learning also does not have any labels. That's an interesting thing. So where are these, what's the two practical examples where reinforcement learning is done? Playing chess, if you think about it, if the computer makes a wrong move, then through our reinforcement learning, we're going to say that, no, you cannot move the pawn, for example, to 2 squares forward. It's got to be moved 1 square forward because it's going to create, going to put you in a dangerous situation. Perhaps your king is going to become under attack, as an example. Or reinforcement learning is also used for robotics, to say that, oh, you are not allowed to go more than 2 steps forward. If you take 1.5 steps, it's still okay, but only up to that amount you can go. And by training the robots, this is how you help them perform tasks. So I want to show you a couple of algorithms that are prevalent in artificial intelligence, specifically in machine learning. What you look at in here is an example of linear regression. And you probably are familiar with this from your science courses. The idea being that we have captured a lot of data. And in this example, we are depicting scores that people take in a certification exam ranging from 0 to 900. And we're graphing hours studied. This is an example of a supervised learning. And essentially what this says, we have managed to draw a line of best fit, which means that this line allows us to have our data as close as possible to the line, to this best fit line. It becomes essentially a linear equation. So this is an example of supervised learning that uses linear regression. So for example, if I want to find out what happens if I study 35 hours, what I need to do is I need to essentially stretch this line further to see what it tells me, what my anticipated score will be. Another example of supervised learning would be an example of decision tree. So what you're looking at here on the left-hand side, we have a situation where we are looking at what's our weather outlook. Is it sunny or rainy? Is the humidity high or low? Is the outlook going to be sunny or not? Is the winds are going to be strong or not? And essentially, we have built a hierarchy in this decision tree, almost like a flow chart, the way you write a program which has a starting point and has an end point. And we use this decision tree for decision making. This example that I have, in fact, I extracted it from one of the dummies books, which the particular example is whether I want to can I go and play tennis or not? And you notice, similar to the way a flow chart will, the last box indicates your endpoint, almost like a leaf object in a tree. I can look at under what circumstances I can play and under what circumstances I cannot play. So you split your data into various branches until you reach the leaf node. And anytime you see a box, this becomes a leaf. If you think about a leaf at the end of a branch, a leaf cannot be broken down any further. Here is yet another example of supervised learning. In supervised learning, sometimes we need to categorize our data into some classes that have been previously defined, and then train the algorithm on that labeled data set. Here again, you see the same model, the same category in terms of how many hours a student has studied and whether the student actually passed the exam or not, and what the model actually predicted. So in this situation, you notice that your classification model, unlike the linear regression, it does not make continuous value prediction. It only needs distinct categories, such as no for not pass, yes for yes pass. So no for fail, yes for pass. So here we compare our actual labels that we get from from the user's exams and compare it against to what the model has done. And whether the model gets it right or wrong, we are still interested to see that because it helps us improve the model. Sometimes it does not mean necessarily the model predicted right. Sometimes it just means that because of our human interaction, maybe there were some things beyond and above the model that could not have been incorporated into it. Okay, so now, one of the next to last topic here is about integration of AI in the cloud. Well, some people might tell me, we all experienced what was the outage of AWS cloud yesterday and the day before. Why are we talking about AI in the cloud? Despite that outage that was experienced, and despite our fragile infrastructure and our reliance on cloud, more and more organizations are migrating their workloads, including AI workloads, to the cloud. Why are we discussing this about cloud? Because cloud brings a lot of important benefits. Scalability. You're going to see in a few minutes that AI requires tremendous amount of horsepower. It also gives you flexibility in what data center can I run this to the one that's the nearest geography to me. And in the long run, because the investments to run AI can become fairly significant, it helps you reduce your costs because you pay for what you actually use. So there are three major benefits in case you have never taken an introduction to cloud computing course. There are three major benefits for leveraging AI in the cloud. This first one is called on demand. Similar to certain boxing matches, certain sporting events that are on demand, cloud also offers you on-demand computing resources. That means when you actually require it. So that means that I can scale up or scale down based on my business requirements. So for example, if we think that toward the holiday season, we need to run our AI models more and more to be able to make more predictions or more assistance to our customers. Well, it makes sense to leverage the cloud and expand the usage of the cloud resources that much during the holiday season. And after the peak of the holiday season is run, we can just go back to the old one. So we can scale down. Scale up and down would be a very important thing. Resource being available as you demand it, as well as cloud providing you with better collaboration among your team members and allowing you to gain access to latest technology. And this is really the big value proposition. No significant upfront costs because the infrastructure is already laid for you. You pay as you go, typically on a monthly basis. And it typically falls under your under your operational expenditures, not your capital expenditures. By now, hopefully, everybody should be familiar with the three major players. AWS by far having the largest market share. I believe the number is somewhere around 35 to 40%. Second ranked is Azure, which I think is around 25 to 30% of the market share. And Google Cloud AI, or some people call it GCP, they run around 15 to 20%. So what is this topic of responsible AI? Why is this important? As you can imagine, AI has progress, leaps and bounds. So we need to make sure as we get deeper and deeper into AI, we don't forget about our responsible development. We don't forget about ethical considerations. Ethics becomes a major, major role. And in fact, regulations, whether in the European Union, whether in the United States or other countries, are trying to catch up with how fast AI has gone on. So let's talk about some major challenges. First of all, data privacy concerns. This is something important to everybody. Does AI step on our privacy? Do we need to ensure that we have robust security measures to protect the data that the algorithms rely on? As you probably have noticed, there's nothing green about AI. In fact, every minute you see that every company comes in and they're trying to find new sources of energy to allow AI to cue the models. So there is substantial computational resources required from processor perspective. And the main reason you see that companies such as NVIDIA have managed to gain a foothold in the market is because they have these graphical processor units that are the workhorses of AI field. You do require powerful hardware, and all of this stuff requires significant amount of resources. So this is one of the major considerations as far as AI. This is not necessarily a data privacy or security issue, but is nevertheless a consideration as far as planning is concerned. And as you probably have noticed, there are requirements for AI is that, hey, now we're going to start, some companies are going to start training individual employees to understand what they need to deal with so that they will be able to better design and develop and manage AI systems effectively. We spoke about responsible AI. You probably have noticed anytime you run a large language model such as ChatGPT such as Copilot, or any of the other tools that are out there, you always see a very small sentence listed at the bottom of each search result that says the results could be inaccurate. That brings up a very important point, that it's quite possible AI models can hallucinate. And they can hallucinate similar to the way humans hallucinate. Remember, after all, we're mimicking human brain. There are 6 major reasons that you need to be aware of as to why AI results could be inaccurate. Remember, we mentioned to you garbage in, garbage out at the onset of our conversation. So the quality of your data plays a major, major role. Remember, we included bias when we were calculating our values in the neurons. So the bias, as well as bias training data, comes up with a flawed output. If I am a programmer that is putting together these AI models, and I don't care to include certain geographic data belonging to a certain geography, well, that's my bias that is going to impact the output. If there is ambiguity in the user input, remember, the clearer your input, the better the output. So if your input is vague, is unclear, similar to the way humans misunderstand, AI models can also misinterpret them. It's true that AI can actually recognize patterns of data based on what you saw earlier tonight, but do they really truly understand what's behind the data? So that's what I mean by limitations in training, being able to go above and beyond. AI can actually perform overgeneralizing, and sometimes this might not be applying to the specific situation. So for example, when you try to apply general rules and those general rules do not apply very well to exceptions, well, that can cause a misleading result. Sometimes AI might not understand what we're actually intending for. So maybe their output is misaligned with our intent. So they probably did not take into account our emotional context. By the way, AI is continuing to improve, but again, be aware of all these 6 major issues. And also another last one is limitations in reasoning. If there is complex logical thinking, if there's abstract thinking, AI at the moment has issue. And notice I emphasize at the moment, because as technology changes, these issues will be addressed. Data quality can be addressed by obviously making sure that more appropriate data and even more relevant data and more cleansed data is fed. So what are some ethical considerations? As you heard me mention when we're talking about robots and using them in customer support, there needs to be transparency. That means the user need to understand they are interacting with a robot, and they need to understand that it's not a human being that is responding to your request. Companies need to be accountable for leveraging AI. In fact, I understand last month, state of California passed a regulation that penalizes companies that do not properly disclose how AI is being used and how they're making their decisions based on AI. So, and specifically about bias. And societal impacts of AI essentially means that AI deployment, as you're hearing it in the news, as you're seeing it in the anywhere else in the media, can impact the society quite a bit. The first impact is you have noticed the employment market has changed significantly in the last 5 years. Our privacies have been stepped on. And security obviously is quite important, that these need to be taken into consideration. So what is this bias and fairness? I mean, almost at the end of the presentation. Bias can essentially cause unfair outcome. The same in regular life. If you bias against a candidate in hiring them, that could look bad on our company. So that means we need to make sure that there is no social inequalities as well as discrimination in our AI models. If there is bias, they need to be looked at and they need to be addressed. And finally, we need to make sure we promote fairness. In fact, Microsoft and AWS both have published how their fairness and bias works as far as training the AI models and as far as the data that you see in as a result of those models. So what are the importance of regulations and best practices? As I said, companies as well as countries are becoming proactive in terms of instituting regulations about how data related to AI is going to be used. There needs to be a governance process in terms of what is our policy, who's going to be working in these, who are my stakeholders, how are we going to go provide feedback, how do we validate that the content is accurate or not, as well as making sure best practices are deployed. You know, we have within the United States government, there is NIST, National Institute of Standards and Technologies. And similar to all the policies they established for the entire United States government, they're also establishing policies for AI, what we call best practices. So in conclusion, there's no doubt about it that AI has revolutionized various industries. They have enhanced efficiency. They have brought about new capabilities that were unheard of or not expected several years ago. They have improved interaction between humans and this technology through user-friendly interfaces. But despite all of those, we need to be aware of ethical considerations. We need to respect privacy. We need to make sure we understand that the data we are sharing is not biased toward a specific group or individuals or a specific background. And with that, I wrap up my discussion and I'm going to stop sharing. So I hope for the audience, you find this discussion of value. I know it was a rush through something we just made it through the 60 minutes. I hope this has whet your appetite to consider investing more time in artificial intelligence, particularly at Touro. I will be happy to share the outcome of this slide deck with the organizers, and they will be able to share that with everybody else. Any comments or questions? Thanks, Mr. Gregory. Again, I hope that this was a good expenditure of your time. Hopefully, it opened your eyes as to what this technology can or cannot do. What are the issues we all need to be aware of as a community? And more importantly, next time around when you are in a meeting, when you're with family and they start to discuss AI and starts to talk about supervised learning, unsupervised learning, computer vision, you know what they're talking about. Thank you very much for attending. And if there are no further questions, I bid everybody farewell and good night.
Thank you so much, Professor Behrooz. Thank you so much for coming, everyone.
Sure.
As he said, this is a taste of what you would learn here at the Graduate School of Technology. So if you are someone, you know, are interested in pursuing a master's in artificial intelligence or any one of our programs, feel free to reach out to us. We have our next workshop coming up next week. So look out for that as well. You're free to join that as well. But thank you so much. Have a great evening. I'll add me and Parveena's contact information to the chat, just in case you're interested in finding out more about our programs if you're not a current student. And have a great night and see you at our next workshop next week. Thank you. Good night.
Good night.